of these aren't going to be on your quiz tomorrow because you're not going to have a calculator on the quiz. So number 1 would be fair game for the quiz because I can make a common base of 3. So this can be written as 3 squared to the x minus 1 power. So, hold on. Because 3 squared is 9. So all I've done is replace the 9 with a 3 squared, and then I'm going to distribute this exponent. So I'd get 2x minus 2 in that exponent, and that is going to be equal to this exponent by the 1-to-1 property. If the base is the same, right, I now have 3 to the 6x plus 1 equals 3 to the 2x minus 2. The 1-to-1 property says if the base is the same, the exponents also have to be the same if they're equal. So I'm just going to go solve this linear equation that 6x plus 1 equals 2x minus 2. So you're really just solving a linear equation, so you don't need a calculator. Subtract 2x, you'd get 4x plus 1 on this side, right? Subtract 2x. Now subtract 1, so you get 4x equals negative 3, so x is negative 3/4. So get your bases the same, set your exponents equal, and then solve the linear equation. So I'm not saying it's easy. I'm just saying algebraically you can do it without a calculator. But there will be probably one like that, you know, with common base for the log or the exponential piece on your quiz. Number 2, you need a calculator for, but it's a pretty quick problem because you're just going to change from exponential into log form and say it's the log base 4 of 12. And I can evaluate the log base 4 of 12 on my calculator. So before last week, we didn't have a way to solve this. You know, 4 squared is 16, so it's 1 point something. Now that we have an inverse operation, taking the log of the function, math log base, so log base 4 of 12 comes out to 1.79. Is that what you got? So we now have a way to solve it algebraically without needing to guess and check. Same thing for number 3. The log base e of 13 equals 2x. This, I don't have to do math log base. I can just take the natural log of 13 because the natural log is a log of base e. So I'm going to take the natural log of 13, and at the end, I'm just going to divide my answer by 2 to get x by itself. So the natural log of 13 divided by 2, comes out to 1.28. Is that what you got? Anyone? 1.28? What other way did you do? Oh, yeah, that's fine. It's just nice to know that E gives you a natural log. You'll need to know that for calculus because E is really used a lot in calculus. Okay? Number 4, order of operation. Oh, question, Ohm? Yeah, at the end, you're going to divide both sides by 2 to get x by itself. So I took the natural log of 13 and then I divided by 2. This would be a test question, but you'd have to use a calculator. So it's not going to be on tomorrow's quiz because you will not have a calculator on the quiz. But number 4 could be a quiz question. Did one of my lights just go on? Oh, that light went on. It is the second day of our competency recovery week. We're going to do a team test the first day and then the test the second day. But it's still going to be part of your quarter 3 grade. So if you needed to retake it, I mean, we still have a couple days. We could figure it out, or I could override it after grades closed. But for report card's sake, I'd like to do it sooner rather than later. I don't think my grades are due until the following Wednesday. So we'd have like Friday, Monday, Tuesday to possibly do a retake. Question? So the competency recovery week, we have regular classes all week, all morning. It's the afternoons that you won't have to show up unless you have to make something up. So you guys are showing up at 7:30 and 9:30 the entire week for regular scheduled classes. So Monday, Tuesday, you're meeting with block 1 and 2 for regular content. It's just in the afternoon that you might not need to stay. So if you have to make up something for block 1, you're staying after on Monday. If you have to make up something for block 2, you're staying after on Tuesday. But like my block, and there's going to be no virtual classes. So like I will not see you Monday, Tuesday next week. Wednesday, Thursday, you'll be here both days at 7:30. We're going to do a team test and our test. And then block 4, we are meeting, they're mandatory classes. This is during class. So then in the afternoon, unless you have to make up something for me, some people are making up a conics test. Oh, did you guys do conics? No. Some people are making up their rational function test, whatever. These 2 days, you should not be staying unless you're making something up, but the mornings are just regular class of quarter 3. And then Friday, you're coming to blocks 3 and 4 in the morning, but that for some people is a new class. For you, it's just you're still coming to my class at 7:30, but we're going to start quarter 4 that day before you go virtual. So I'll give you your new virtual packets, which will be a new unit. What would you come back for? Yep. There's lunch in there, but most people are leaving. It would be, yeah, so they're doing bagged lunches. They're doing bagged lunches as you leave to go out to the buses. Like people are leaving at 11:25. You don't even need to have a dismissal slip. You are leaving at 11:25. Yeah, they're running a bus. They're running 2 buses that week. So anyway, if you have questions, but it's a regular schedule. Oh, I just recorded that for Ava too. Oh, sorry, Ava. Okay. All right, 4. Number 4. And then I think we'll do a couple minutes of 121 and go for our walk at 9:30 and be done. Okay? Because to go for a walk now. So anyway, order of operations, we would divide by 2 to start with. So now this 2 is gone. So you got log base 2 of x equals 4. 2 to the 4th power is 16 should have been your answer. Question. You got 2 to the x equals 2 to the 8th power. It's not 2 times x, it's the base of 2. So it's a subscript. It's not 2x inside the log. Your first step is to divide by 2 on both sides. So that gives you this log by itself equals 4. And then 2 to the 4th power equals 16. 2 to the 4th equals x. So x is 16. So 4 would be like on the quiz without a calculator. You're going to do some like that on the practice tonight for the homework. Number 5, I think you need a calculator for this one, right? Natural log. So see how this is not connected with a parenthesis? Your first step would be add 4 to the other side. The second step would be divide by 3. So the natural log of x is 4/3. And then your last step is to convert to exponential form. The base is e. E raised to the 4/3 power is going to give you your answer. So on your calculator, you would do e raised to the 4/3 power. 3.79. Did anyone get that? Did you estimate or did you get full? You estimated? Okay. So it wouldn't be close enough for full credit, but it was along the right lines. And I think 6 you can do without a calculator. You would subtract 3 first because these are not in parentheses. So negative log x equals 2. You would divide by negative 1 on both sides. So log x is negative 2. And then you're taking 10 raised to the negative 2nd power, which is 1/100. So you could do that without a calculator. So what's the hard part? The order of operations? So before you can switch forms, you either need the exponential part by itself or the log part by itself before you can switch forms. So just don't switch forms until you're isolated. Yeah. The base of a common log is 10. So there's no base written there. The base is 10. Just like over here, the natural log, its base is e if it's not written there. So it's kind of like the square root symbol. If you take the square root of 16, do I need to tell you it's the square root of 16? Right? That is the common square root. So if I want it to be the cube root, I have to write cube root and change the index. So if I want you to take the log of 10, you know the base is 10. I have to specifically write a different base if I want it to be a different base. If not, you assume that it is 10. All right, I just want to introduce you to the applications because I want to be able to get through it, the rest of it tomorrow. And then we'll go for our walk outside at 9:30. So I just want to do the first couple together just to plant the seed so that by tomorrow we're really digging in. This formula here is related to the compound interest formula. PE to the RT. P is your principal. A sub 0 is your initial population. They're related to each other. E is still E. K is your interest rate. It's just called R in interest, and T is still time. So you've worked with this a little bit in compound interest, and we're going to practice compound interest again probably on Thursday. But so in our last adventure a while ago, we looked at compound interest formulas and we used PE to the RT during our virtual week. So it turns out this formula is simply just one form of A sub 0 e to the KT. This looks horrible, but basically this formula is used when you've got a population that's growing uncontrollably. So we're going to be talking about cooling rates of liquid. We're going to be talking about population growth. We're going to be talking about radioactive decay of an element. So it says in the formula A sub 0, it just means the original amount. You don't plug in 0. 0 is not a number. 0 is the subscript to tell you initial times 0. So A sub 0 just means how much did you start with? K is a constant. T is time. And if K is positive, it's increasing, like population growth. If K is negative, it's decreasing, like radioactive decay. Classic examples are compound interest, unlimited population growth, or radioactive decay, like I said, for carbon dating. The simplest applications just involve when you already know your initial amount, your K, and your T value. So example 1, we don't have to do a whole lot to solve this. I just want to show you that we're using this same formula. The size of an insect population at time t in days can be modeled by this equation. Population equals 500, that's your initial insect population, E to the 0.02 t. What's the population after 1 week? What am I going to plug in? 500 times E, yeah. 0.02 can't change, that's a constant. 7 for 7 days, right? So I'm just using the formula that I have and evaluating for a certain time. So to me, this is considered the easiest form because you already were told the constant, you were already told the initial population. So 500e to the 0.02 times t. What is your insect population? About 575 insects, approximately. You could round down to the nearest insect. You could round up to the nearest insect. I'll count you right either way, as long as you're using this equation. So it says sometimes we know the value of the current population, but we don't know the original population. We know K, we know T, and we have to solve for the original population. In this case, remember, it may look intimidating, but e to the KT is just a number, right? E is a constant, K is a constant, and T is a number. So you could evaluate e to the KT, it's a number. So this says the current size of an insect population has reached 10,000 organisms. A researcher determined the value of K as 0.05. What was the population 3 days ago? So this time we know 10,000 is our end result, but we don't know our original population. We know that E is a constant. It tells you K is 0.05, and it's been 3 days that have passed. So the reason they're telling you up here, this is just a number. So you can evaluate this number and then divide it to the other side to get A sub 0 by itself to solve for the initial population. So you're just getting familiar with manipulating the parts of this kind of complicated expression. Question? Yes. For this situation, sometimes T is the number of hours or the number of years, but you look at that certain situation. Okay, T. So you're doing E to the 0.05 times 3, and then whatever you get, you're dividing 10,000 by that result. So it should be smaller than 10,000, right? Because this is the initial population that's growing. If you got a number in the 8,000 range, you're correct. So did everyone try the calculation question? Good. Yeah, because you're going backwards 3 in the table. So that's fine if you understood what you did. I don't know if you always want to do it that way because you're going to be solving for K pretty soon. But yeah. So did you get 8,607 about? And I did it with parentheses. If you want to take E to the 0.05 times 3 first, get an answer, you all know that you can type 10,000 and then go arrow up and select that exact amount to do the division that way on these calculators, right? If you want to grab that number. All right, there's just one more that I want to do so that I've shown you how to solve for K, just to plant the seed for next time. The most common problem involves finding K, right? You're the scientist, so you're studying a certain population in a certain situation, right? Insects are going to grow different at different times of the year in different ecosystems. So in this case, you're studying a certain element, carbon-14. You dig up a fossilized leaf and you want to date it. How old is it based on how much carbon-14 is left? It could be 1,000,000 years. It could be 500,000, 1,000. So your current leaf contains 30% of its normal carbon-14. How old is the leaf? We can't answer that until we can find K for carbon-14. So it says the half-life of carbon-14 is 5,600 years. Do you know what a half-life is? If you start with like 100 grams of something, after 5,600 years, how much of it would you have left? If it's called half-life, you have 50 grams of it left. That's still quite a bit of that element. After another 5,600 years have passed, how much would you have? 25 grams. That's why when you have radioactive spills, like at Chernobyl, the radioactive elements are there a long time. Because even if you have a little bit of it left, it takes so many years to break down another half of it. So it says to find the value of K, here's what we're going to do. We are going to pick 50 as our end result and 100 as our starting point. It doesn't tell us how much we have. You can pick any number here that's half as much because it's a half-life problem. E, I don't know K, but they told me that 5,600 years was the amount of time it would take. I have to solve that for K. So after we solve for K, I'm going to stop so we can go for our walk. But what would be my first step to solve this for K? Divide by 100 on both sides. What magic number do you get over there? Half or 0.5, half-life. E to the K times 5,600. What would be your next step? Can't divide by E. It's an exponential problem. You're going to turn it into a log problem. right? So I'm taking this base, the log base e of 1/2 equals k times 5600. Would you agree those are equivalent statements, right? E to the k times 5600 equals 1/2. E to the k times 5600 equals 1/2. This I evaluate. It's really just the natural log of 1/2. And then at the end, I'm going to divide by 5600, and I'll have k to use next class for actually solving this problem. So take the natural log of 1/2 on your calculator, divide by 5600. It's a really, really small number. That number is negative 0.00012 if I round it, right? Because e to the -4 is scientific notation that says you're going backwards 4 decimal places. So we have k, and I can show you how to solve for that next time.